Now, in this problem, what should be acceleration of this wedge big M in rightward direction A0 so that this smaller block remains at rest on the inclined plane? Is it clear? What is question? Question is what should be A0 on the rightward direction of this wedge so that the smaller block, so that M remains at rest on the inclined plane, rest on inclined plane. This is the question. Now once this wedge is accelerated in rightward direction, then you will observe this wedge will act as a non-inertial frame. And since this mass M is placed on the inclined plane, so this you will observe is to analyze the forces, we have to apply a pseudo force on this smaller block, that is equal to mass of the block into acceleration of the non-inertial frame. Since acceleration is rightward, so pseudo force act on this M will be in leftward direction. Now two more forces are acting on this. One is the weight of this smaller block in downward direction, that is mg is acting in downward direction, and one normal reaction will be acting perpendicular to the inclined plane like this. And since this angle is theta, you will observe that the angle with this weight makes is 90 minus theta. This is 90 minus theta, and this will be angle theta, and then this will be 90 minus theta. Is it clear? The angles are clear. Now since this M is at rest, since M is at rest, then we will observe the force, the component of MA0 up the inclined plane. Up the inclined plane is MA0 or sine 90 minus theta, that will be simply equals to cos theta. Is it clear? And the component of weight in down the plane will be equal to mg sine theta, right? So since M is at rest, I can say the component parallel to the inclined plane in upward direction is ma0 cos theta should be equal to mg sine theta, and I can say then the acceleration which should be given in rightward direction to keep the smaller block at rest should be equal to g tan theta. This should be acceleration on the rightward side direction for the wedge. Then only this smaller block will be at rest. Now suppose the let A is acceleration greater than A0 given to g tan theta, right? Suppose the wedge is now accelerated with A in rightward direction, which is greater than A0, that is g tan theta. Then you will observe in that case this component ma0 ma cos theta will be acting in upward direction, mg sin theta will be downward direction. Since this acceleration will be more, so the block will go up. M will go up the incline, and what should be acceleration? What will be the net force acting up? That will be equal to m a cos theta minus mg sin theta, and that will be equal to mass into acceleration of that block in upward direction. And I can say then the acceleration up the plane equal to a cos theta minus g sin theta will be the acceleration up the plane if A is greater than A0, right? Similarly, if A is less than A0, suppose I say A is less than A0, that equals to G tan theta, in that case the block will slide down and acceleration down the plane will be equal to now mg sine theta minus ma cos theta by m, and it will be equal to g sine theta minus a cos theta. Will be acceleration of the block down the plane, that will be relative to the inclined plane. So, but if acceleration this wedge is given as g tan theta, in that case this smaller block will remain at rest and it will be unaccelerated, relative to the plane, relative to the inclined plane it will be remain at rest. But if acceleration of the wedge is greater than g tan theta, then this will go up because this component will be more than this, and if acceleration is less than g tan theta, in that case this will come down. Mg sin theta will be greater than mu, and then I can say acceleration g sin theta minus a cos theta. Okay, thank you.